Hello mathematicians, puzzlers, and other curious people. In this video, we are looking at the Math 0325 review guide, specifically the problem on histograms. So we've got a histogram here. Remember, that's basically a bar chart where each bar represents a small part of the data set, a particular range, such as from 40 to 50. And we're told that the gestation length in days histogram, labeled right there, records data for the duration of a pregnancy for a sample of a particular animal. I don't know what species this is. It didn't tell me in any of my materials or right in this problem. If you want to try and find that out, maybe find some species that would be consistent with this, that could be interesting. So it seems like through here is where most of the sample is, so I guess that's the lengths of the normal healthy pregnancies in this species. And then over here we have a much lower cluster, and I'm guessing that that would represent typical premature lengths. But again, I'm not sure what species this is, so I don't know for sure. But it looks like most pregnancies, and I would assume that that means in general the healthy ones, run between 120 and 160 days in this species. So that would probably be a starting point if you want to try to research and find out what species this might be. So we've got two questions that we're trying to answer based on this histogram. The first is, how many animals had a gestation length of 140 to 149 days? So to answer that, we'll look for starting at 140, so coming across here, because we're talking about days, so that will be within this part of it here. So coming across here, starting at 140 and going up to 149, well, that will be just before 150. So that'll be this bar here, and then going across to see how many that is. It looks like it's right on the grid line. Let's see, all the way across brings us to 25. So that looks like out of this sample, 25 of the animals had that gestation length. Now we have a follow-up question. If the graph represents data for 109 animals, what percent of the animals had a gestation period of 140 to 149 days? So when we say what percent of, that tells me, again, we've got a part out of whole type situation. Now 140 to 149 days, that's the same as we dealt with right here. So that part is going to be the 25 that we just found. Now the temptation would be to just say 25% and leave it there, but that would be wrong. Now if it happened to be exactly 100 animals in the data set, you could get away with that. Now the second temptation would be to just multiply it by 100 and put a percent on it. But then we'd have 2,500%, and you never go above 100% in a part out of whole relationship. So that would also be wrong. So don't do either of those things. What should we do instead? Well, the usual way for a part out of whole relationship is we'd say 25 out of the whole. What's the whole? We could find this out by going across and adding them up, but conveniently, the problem gives us something that we can use as a shortcut. If we didn't have that, we'd just say, okay, 4 and 5 and 3 and 2, etc., all the way across, estimating the numbers when they fall between the bars best we can, but it told us, so we can skip that. So we've got 25 out of the 109 in all, and then we can grab our calculators and divide that. I'm expecting it to be just a little less than 25%, by the way, because I noticed that it's just a little bit bigger group than 100. So now I hit 25 divided by 109 into my calculator, and my calculator says that that's 0.22935 blah blah blah. Okay, but it wants a percent. Well, that would be about, and it doesn't say what to round to, so I'm just going to make a judgment call that I'm going to round to the nearest whole percent. So that would be the 9 bumps up the 2, 23%. And I noticed that's consistent with what I had estimated because it's a bit less than 25%.